Hello Internet, in this video we are going to be working on creating a hologram shader. I don't know entirely how far we're going to get with this. I don't really know what we're actually going to build. But we're going to start by just kind of using some world space positions to actually render the hologram, and then we'll tweak it a bit until it looks really cool. So traditionally, holograms just projections of light. So we're going to use an unlit shader because it's a light projection. So it's just light reflecting off of particles, so the light is already there. We can just give it the lighting. So I'm going to do a hologram shader. And what I'm thinking is traditionally, like if you look at classic holograms, you just have these normal scan lines or something that go along the y-axis. And so those just usually crawl up or down. So we're going to need the time and we're going to need the world position. And both of those are actually fairly easy to get. So here, looks like Vertex and fragment shader is what this gave us. So not a surface shader, that's important. So the difference is a surface shader can include a vertex shader, but traditionally a surface shader just is a fragment shader, which actually renders the color to the screen, but it includes all of Unity's lighting already pre-built into it and has a few extra steps and compilation that happen prior to actually getting it into your game. So this is giving us a fragment shader, which is actually going to mean the output of this fragment shader is just a color. It's just a 4-point or a 4-dimensional array, which is going to be our red, green, blue, and alpha channels. So whatever we output here is whatever is going to draw to the screen. So if I change this color to just be red, so just do a fixed 1001. So it's going to be red, green, blue, alpha, which if you do 0 here, you're not going to get anything. So there's some other things there. One thing to keep in mind, just changing this alpha channel isn't necessarily going to get you a proper alpha. It's going to have a few sorting things that are going to come into play. So some of the stuff behind it won't actually draw. And we might be able to demonstrate that quickly. But what I'm going to do is create a really quick material here. So if we throw together a hologram material like that, throw our hologram shader on there, we're going to get pink. Because I did not type that right. Color. This should be better. That's still not going to work because we're actually using Cull, C-O-L. So if we use that, this should compile-ish. Incorrect number of arguments. Fixed 4. We actually need to specify the number of arguments. This is going well. All right, we get red. Very red that I can't put on. There we go. So this is completely unlit. It's just red. Now, if I go and actually stick, say, 0.5 on here. I don't actually know how this works. I don't know if it will. But that's 0.5 alpha channel. I think there's a little bit of extra stuff that goes on here that's going to stop that from happening. So we actually won't see it be transparent, but I should be able to make it 0. Again, this is a guess. No? Okay. Ignore both of those. Alpha channel is ignored unless we specify it to actually render with the alpha channel. Cool. There's compile flags, so you'd specify that up here, that you would like it to be an alpha shader. So if you're using normal, like standard shaders, that'd be fade or transparent, or the alpha clip. But anyway, we don't care about any of that. What I do need is it looks like we're getting a vertex position here. So I wonder if I can just use that. So let's multiply this out. Let's just do mathf.sine, and we're just going to plug in our input vertex dot y. This should be the y position of our what am I doing? Mathf is Unity script stuff. We don't need that. We just need sine. What? What? Oh, ha. No matching parameter for 4 arguments. Got it. Okay. Going a little bit crazy here, but there we go. Cool. So we get these red lines, and this is going to be in screen space, which is interesting. That's not really what I want. Is it in screen? Yeah. So we have these screen space scan lines, which looks kind of interesting because it's screen space. So as you move away, everything shifts with that. We don't want that. It's cool, I guess, but we don't want that. The issue we're going to run into there is I have no idea what's going on. So let's see. This is going to project our vertex position into the projection space, which is going to be what the camera actually sees. So there's a sheet of paper that our camera draws onto. This final vertex is in that coordinate space. We don't want to work in that coordinate space because that's screen space. It's just what's on your monitor. And this vertex is going to be related to the object. It doesn't include the world space. So what we need to do is there is going to be another one, I think. Yeah, pretty sure I'm saying this correctly. There's going to be another vertex, or we're going to need another matrix multiplication to go from the object space. Do we want to do it in object space, or do we want to do it in world space, or do we want to do it in object space? Because if we want to do it in object space, we already have that. But if we want to do it in world space, we have to do some transformations. Let's just start with the easy one. So I'm going to do float for object vertex. And this is just going to be a texture coordinate, because if you need extra labels, that's the easiest way to get them. And all I'm going to do is literally just take this and write our object vertex equal to our input vertex. So v.vertex. So this is just copying that value that is coming into our vertex shader and giving it to our fragment shader. So now instead of using this this vertex here, we want to use our output vertex, which should be in object space. Let's actually spell that right. Apparently that's the trouble we're having today. I can't spell anything correctly. Neat. So we get this giant red thing. That's not entirely what I was hoping for. So my guess is that the scale is too small. So we are going to increase that by a factor. And there we go. So now we have these scan lines that are appearing, and they're in object space. So because they're in object space, I can move this object around and I can actually rotate it, and everything kind of stays related to that. That's the difference between doing object space and world space. If I was using world space, when I move this object, those lines would stay in place and the object itself would move up and down. So I don't know what's the best. I feel like using world space is more, it just makes more sense. So to give an example, let me actually figure out how to do this. There's a multiplication of some Unity matrix. Let me go pull that up because I don't have these memorized. There's some shader function too that it will translate it to, but I don't know that either. So we're going to figure it out. But I'm going to translate this vertex into world space, and we'll kind of compare the two results. So that was easy. It turns out it's just called object to world. Who would have guessed? I didn't. So the multiplication is going to take our current object space vertex, which is just the model, and then it's going to multiply that by the world space projection matrix. So this is a matrix that actually represents sort of the world space. It represents the actual object in space. So since all of these objects are actually at the root level, they're at the scene level, this transformation right here can be kind of viewed as that transformation matrix. It's saying we have a sphere that is located at 0, 0.2 something small, and whatever, it gives it the scale and all of that. That gets translated into a matrix when you're drawing this thing. And then that actually gets all of the vertices in this actual sphere get multiplied by that matrix to actually get us the final render. And then it goes a few steps down to actually get it onto the camera, but that will get it into world space. This transformation is what is doing that. So hopefully I can move this now, and you can see everything kind of moves with it. So we now have sort of a moving hologram thing. It's super basic. It's just lines, but you can kind of see sort of where we're going with this. The next thing we want is going to be, what do we want? I think the next thing we want is probably alpha. We want that red. I'm actually going to drop the red, and I'm going to pull out the fog. Do I want to do that? So right now, Unity includes its fog multiplier. So if I go back here, go to lighting, and just add some fog, like so. Don't know how this is going to work. I've never tried this before. Don't really use, nope, doesn't work. Okay. We got a bunch of errors. Duplicate input semantic. Texture coordinate. This Unity fog coordinates needs to have an index equal to the next available texture coordinate. I'm pretty sure if I remember that correctly. So that should compile now. And we have fog enabled. It doesn't turn white. I was kind of expecting it to turn white. That would have been nice. What am I doing wrong? Well, I have never actually used Unity's fog. Since this, I usually use an asset for that. So this is almost entirely my fault. But I don't really think I need to fix that right now. I don't really think that matters. So we fix the fog. That's cool. It doesn't actually break anything, but it doesn't work either. And I don't know if that's something I did or not. So we are going to ignore that because that's what I do with all the problems. Right. Alpha. We need to make this transparent. How do we do that? I don't know. It's going to require a pragma shade or pragma command here. That's going to say this is an alpha shader. Actually, it's not. That should work. That's not gonna work at all, but okay. What's the best way to do this? Cosine of 1 times actually object vertex dot y times 100. Cool. Yeah, that ought to work. Nope. Missing something. Parenthesis. Of course we're missing a parenthesis. Why wouldn't we be missing a parenthesis? So, there's 2 things I want to do, and then I actually want to look up how to actually do this transparency because it's not working, and it's almost entirely my fault. So, I'm going to stick a multiplication here, and pull it actually out of our color. And then instead of using this fixed 4 everywhere, we're actually just going to use a color. It'll be easier to just do color. Cool. So let's call this R. We can just use fixed 4. It's already what we're using, so it makes the most sense. And then let's get up here. We've got our main texture. Let's also grab a color. We could keep the texture here, or we could not. It doesn't matter. I'm not using it, so it doesn't really make sense to keep it around, but we're going to anyway. Just because then there's cleanup and stuff that would have to happen. And that's just more work than I want to do. So, yeah. That was a thing. That's not how you do that. What have I done? I have done something horrible. Shoot. Is that not how you do a color? That might not be how you do a color. I have a few things to look up. Let me check in on this, and then I will be right back, and we will have alpha and color going, and it will be great. So this is what it looks like right now, and I have done exactly the bare minimum to get this working. So there were a few changes that had to happen. First off, we had to turn off Z writing so that anything drawn behind this transparent shader is not culled. So just let me show you what that means. I'm going to take this cube. It's behind. You can obviously see it. But if I go and turn this Z write on, it still may show up, which is cool. But then if I move it over here, what am I thinking? That's not going to work. It's going to start culling things. Or not. Oh, sorry, that bad example. Two of these cubes. I can clearly see the other one behind this one, but if I go to the other side, I can clearly see the other one. These have both been really bad examples. I'm gonna need, I'll do a different video on why that happens, because I am not thinking about this correctly at this point. The other thing, got the color working. I was close, but I was making it more... I was thinking it was simpler than I wanted it. So you just have to actually give it the values. Done. It's white here. I changed it to be blue because why not? And then we have our blend, which is going to take the source alpha, which is whatever the source, the already rendered content has. And then we're going to just, wrong way. It's going to, the source is our alpha, us. And the next one is just blending in that with whatever is already there, minus our source alpha. So whatever's behind comes into the scene with that same strength, just minus whatever this guy's transparency is. So if this is 1, the background scene has a total value of 0. If it's 0.5, the background scene has a value of 0.5. And so it blends them that way. Then the next thing... Was there a next thing? I don't think there was. I think that was it. So, a few simple changes. Missed one thing. We had to change this to be in the transparent queue and have a transparent render type. If you don't do this, you'll probably get more of what I was talking about. So if you make this opaque, if you keep it opaque and you start mixing them, it's going to be rendered with your opaque geometry. And if it's writing to the Z, to your depth buffer, what's going to happen is your depth buffer, at least with opaque geometry, it normally wouldn't matter if you were writing how you draw things. So if you draw something really far away and then you draw something really close, that doesn't matter because the close thing just prevents it from drawing. But there's an optimization that happens and just a better thing that happens. So if something is in front of it, you obviously don't want to draw what's behind it if that comes second in the queue. But when you're doing transparent things, you want that to happen. If you didn't draw what was behind your window, then you wouldn't see anything out the window, and that obviously doesn't work. And so what happens is, with transparent objects, it actually draws them from the things that are furthest away to the things that are closest. And all transparent objects are rendered afterwards. They're all rendered after the normal scene. And so that ensures that no transparent object clips anything. If you disable that, if you don't have that happening, if things are just drawn randomly in your transparent queue, some things will occlude other things. And when that happens, they just make things disappear that shouldn't disappear. It actually looks really interesting, and it's really difficult to tell what's going on. But if you see that, that's what's happening. That was a long tangent about transparent things. We will do a total video on that because it's an interesting topic. Anyway, we have this. One of the interesting things that happened is you'll notice we have these white lines. I don't entirely know what that is, but I suspect we can get rid of them really easily by doing a non-caps locked max. So 0 to our cosine. So if it goes below, it will go away, and all of those white lines disappear. So apparently negative values give you very bright values. Anyway, we now have this fancy little sphere. There's something missing though, and if I go inside it, it should be obvious. It's not there, and the back doesn't really show. With a hologram, we kind of want that. So I'm actually going to do a cull off. And so by doing this, normally anything with a normal or with the wrong, we've talked about this a few times before, but there's winding that matters in the vertices. And so if you don't get the winding right, well, I don't really have the time to explain this, but effectively think of the winding like on a clock. So if you have some the hands on a clock that are going a certain way, no matter how you look at it, as long as you're looking at the clock the correct direction in the way you would read it, the hands will always go clockwise. But if you go behind the clock, no matter where you are, as long as you're behind the clock, those hands are always going to go the opposite direction. They're always going to look like they're going counterclockwise, because that clock that was going this way is suddenly going this way. And that might have looked weird because I think I have my camera flipped. Yep, okay, that was wrong. But anyway, you get the idea. Things flip when you rotate something and look at the back side. And so that's actually used in culling. And so the graphics card knows you give it those three vertices that make up a triangle, and then it figures out which way they're drawn and which way they actually appear. And if it looks like it's forward, then it draws it. If it looks like they're backwards, then it doesn't. And so the way that actually works is fun because it means you can actually remove this culling. And we are getting some of that Z fighting stuff. So I guess we can actually explain it a little bit. You can see some of the back lines are actually drawing over the forward line, the ones in front. That's not entirely what I was going for. Like this is very clear. The lines in the back are actually drawing over the ones in the front, so the really thick forward-facing ones are getting overlapped by the ones behind it. Obviously, that's not what we want, but we should be able to fix that. What if we mix the color instead of the alpha? That doesn't really work. Kind of blends it out a little bit, but it doesn't really do anything. So that's just a color blend, which effectively moves the colors towards one another. It doesn't actually change the alphas or consider them. So that's not really what I want. That was just a really poor example. Let's see here. I want to take the... Let's take the source alpha. And I think we can just do one, though that might not work. Yeah. So what I made there is sort of a really basic additive shader. It just takes the current color, the color that's behind there, that's already been drawn, and then it adds on whatever color we added. So all of those overlaps kind of don't matter anymore because it's all additive. It's light. And so they just get drawn one on top of the other. So it actually doesn't matter. We don't need to worry about solving that problem in this case. And I didn't really want to solve it anyway. So yeah, scanning lines, we have those. And it looks kind of fancy now. So, really basic additive shader with some scanning lines. Let's add a really fun animation to this. So I'm going to just do time.x. I don't actually know if that comes in, but we'll see. It looks like it, but I don't see any animation. If I start this, it might work, but that would be weird. Oh, you know what? I bet I know what's going on. We're just at a super small scale. So let's multiply this by, say, 100. This should go really quick. Yeah, there we go. So now we have animated scan lines. And this shader can be put on pretty much anything. And we can move it around too. So if I take this and kind of drag it around, you can see everything kind of looks fancy. I don't know, it's a basic hologram thing. It's not... Obviously this is a little bit simple, but you get the idea. And we can kind of tweak this however we want. This is close to what I was going for. I just want to expose some of these values. So this one, we're going to talk about the scanning. What do we want to call this? The scanning frequency or scanning speed. This is going to be the scanning frequency. And is there anything else we want? We may want a cutoff. And what I mean by that is, well, this isn't going to work anymore. But we have those lines. There's going to be a equal gap of nothing for everything that is there. And so what if we want to fill in more of that gap? What if we want to bias? And so we can actually introduce that a little bit by actually adding on a bias here. And so this bias, if we make it negative, it's going to make those actual lines that are drawn smaller. Yes, it should make them smaller. If we increase the bias, it will make it thicker. And if we increase it all the way to 1, then we just get a solid glowy thing, which probably isn't what we want, but it's possible. So we need to introduce a bias, which is going to be just bias. And that can just have a range. I think this is valid. We're going to test. I don't know if that works, but I'm going to pretend like it works because I'll feel really happy if it does. Then we're going to add a scanning frequency. And so this is really just taking all of those values we wanted to add and copying them over into our actual shader. So we were using 100 before, so I'm just going to keep that. And then we have our scanning speed. So we're going to take that, plug it in as the scanning speed. And that can be another float at 100 as well. And that should be everything we need. If there's anything else we want to add, we can do that. And what we could do, which is interesting, is we could actually apply additional effects over more than one axis. So right now, this is strictly going across the y-axis. We could actually add additional waves going across anything. That didn't work. Why didn't that work? Oh, ha! Yes, we do actually need to specify these. So we have the bias, the scanning speed, and the scanning frequency. So what I was going on about is we can actually introduce additional values that make this work a little bit better. That range did not work. I'm not super keen on getting this to work if we can just use a float. Cool. It works, I guess. Neat. So this is entirely the same thing, but you can see as I increase this bias, it gets more and more complete. And since we have that, we're drawing both sides, we can actually see it from the inside. So if you need a shield, I guess you could use that for this. Don't see why not. But that's a little bit too much, so we're gonna tune that down a bit. And that looks good. Sure. Probably look better at night, but whatever, it works. If we increase the frequency, we increase the frequency. And so now we get these really nice tiny lines and that really fun shape. This is happening at the top. This kind of looks a little bit weird. And that's just because this is a low poly sphere. And so it can only be as precise as the triangles. It's just taking the world position. And so each of those triangles there is going to have a linear scale across it. And so it looks very linear across those bits. But you can fix that if you need to, or just add some tessellation and that will also fix it. But yeah, we don't need to worry about that. I'm going to bring that back down because that was excessive. We can increase our speed and then it looks very hyperactive. We can also make it, if you want to go from bottom to top, which I think is more traditional, you can just invert that and just make it negative, everything works. It all does what you would expect. And you can definitely tweak it however you want. I'm going to quickly add, just as sort of a proof of concept, something along a different axis. And so this is actually going to, do we want to add to that or do we want to multiply? These are the choices we have. I'm going to multiply it because I think that'll look really cool. But I'm going to multiply it by 1 minus this value. And I'm going to take this bias and add on 0.9. And we're going to do i.object vertex.z. I don't know if this is going to look exactly how I want it, but it's going to be along the xz axis, so sort of diagonal. Nah, we're just going to do across the x-axis. That's just simpler. It gets the same effect. Instead of making it diagonal, we wouldn't care. And then all of that other stuff is good. And now we get these fancy dots. And so they're still going up because our initial function was saying they should go up, but we also have them panning across it, going along the x-axis, that red arrow there. And so now we just get these fancy dots, which, I don't know, it looks pretty interesting. But we do still get this. So what if we don't want that either? Well, we can fix that too. And we can just make this go along the z-axis. And I don't actually know if this is going to work because I hadn't tested any of that. But there you go. There's a fancy little sort of, I don't even know if that's actually, does that actually count? I don't know. It looks sort of hologrammy. It looks very futuristic, but you can tweak this however you want. Whatever look you're going for, I'm sure you can replicate it with this. There's not much to it. It's just a bunch of what math function can you apply over this. If you want to get really advanced, you can do some like noise functions or whatever to actually like have some jitteriness, some glitches in the system. So I'm going to leave it here because this is trippy. But yeah, I don't know. I think it's cool. So if you guys work with this or change it or do anything, let me know. I'm going to have the code, the source code for this shader down in the comment or in the description, so you guys can check it out there. If you have any feedback for me or anything you want me to improve on, let me know and I will definitely look into that. Consider joining the Discord channel. We have some interesting conversations there and people are sharing some really cool stuff there. But that's it for this video. So until next time, see you, Internet.